For millions of years, something has been racing through space at nearly the speed of light. Galaxies are normally millions of light years apart, but gravity can bring clusters of hundreds or thousands of galaxies together tightly. When galaxy clusters get too near, gravity can push them tighter and tighter until they can't escape, leading to cataclysmic collisions. Scientists recently stumbled upon one such collision while investigating the universe. What's the latest discovery? Stick around to hear all about this strong force that has been traveling through space for millions of years. Our solar system is within the Milky Way galaxy, which looks like a hazy strip of light from Earth. The Milky Way is part of the Virgo supercluster, which is nested within the Ionia supercluster. Astronomers suggest that the Milky Way is accompanied by countless additional galaxies. It's expected to hold between 100 and 400 billion stars, coupled with a corresponding amount of planets. Our solar system is positioned around 27,000 light-years out from the galactic center, on the inner edge of the Orion Arm. At the heart of our galaxy sits Sagittarius A*, a supermassive black hole with around 4.1 million times the mass of the Sun. Stars and galaxies orbit the galactic center at a speed of roughly 220 kilometers per second. This rotating speed contradicts Keplerian dynamics, leading scientists to conclude the existence of dark matter, which doesn't produce or absorb electromagnetic radiation. When seen from other galaxies, the Milky Way is calculated to be traveling at around 600 kilometers per second. Recent studies indicate that the oldest stars in our galaxy are nearly as old as the universe itself, suggesting they formed shortly after the Big Bang. The Milky Way, along with Andromeda, is regarded as one of the two biggest galaxies in the local group. The Milky Way's mass ranges from 890 billion to 540 billion times that of the Sun. Advanced technology has revealed a plethora of phenomena within our galaxy, including billions of stars, planets, white dwarfs, neutron stars, and stellar black holes. The interstellar medium, a disk of gas, covers the space between stars. However, important events also occur beyond the Milky Way. Recently, scientists have detected something exceedingly unsettling roughly 730 million light-years away from Earth. Astronomers are drawn to massive explosions and collisions, always hunting for bigger and brighter ones. What could be more enthralling than the collision of two of the greatest objects in the universe? In February 2022, the Journal of Astronomy and Astrophysics presented a stunning study exhibiting one of the most comprehensive photos ever obtained of a large shock wave. This fascinating occurrence happens within the galaxy cluster known as a 1367, which gained its name from the collision of two galaxy groupings. A 1367 is a lively cosmic hub holding a group of 550 galaxies that are progressively merging into a massive cosmic soup. The massive shock wave observed by astronomers is the direct result of this merging event between the two galaxy clusters. Although this cosmic collision remains undetected through most telescopes, it has released an enormous disturbance wave in the neighborhood. Experts characterize this shock wave as a tremendous disruption erupting from both ends of the merging cluster, visible only through radio wavelengths. Researchers in South Africa utilized the Meerkat radio telescope array to visualize the radio relics of both portions of the shock wave. This investigation shows complicated structures beyond previous imagination. According to Francesco de Gasperin, the lead author of the study and a visiting scientist at the Hamburg Observatory in Germany, shock waves operate as giant particle accelerators, accelerating electrons to nearly the speed of light. These waves reveal a complicated pattern of light filaments, indicating the positions of enormous magnetic field lines and the places where electrons experience acceleration. While the shock wave is a recent finding, its origin stretches back nearly 1 billion years ago when the two galaxy clusters constituting a 1367 collided. When such enormous galaxy clusters combine, an immense amount of energy is liberated, as they constitute some of the most massive gravitationally bound objects in the universe. Researchers believe that this event is the largest single discharge of energy since the Big Bang. 1 billion years ago, during the collision of the clusters, a flood of electrons was released, flying across space at an astonishing speed of 1,500 kilometers per second. As these particles transit magnetic fields, they generate radio waves. Dr. de Gasperin and his team detected these radio waves using Meerkat. Although radio waves alone proved insufficient to completely define the shock wave, the Chandra X-ray Observatory also helped with the analysis of a 1367. Upon close observation of the image, one can detect the central cluster of 550 galaxies, while the surrounding red hues indicate the shock waves generated during the supercluster creation. This result constitutes a paradigm shift in the study of galaxy cluster mergers, highlighting the complicated processes at play during these cosmic collisions. Sometimes the lack of something creates a greater conundrum for scientists than the presence of unexpected happenings. In 1981, astronomers at the University of Michigan embarked on a quest to compute the redshifts of multiple galaxies, producing a 3D model of the cosmos. As the image unfolded, scientists faced a startling revelation: a large gap around 700 million light-years away from Earth. This nearly spherical region, spanning over 330 million light-years, contains practically no galaxies. Initially dubbed the Great Nothing, this intriguing void eventually gained the moniker the Boötes Void, lying within the constellation of Boötes. Subsequent thorough maps of the universe revealed that galaxies predominantly cluster along filaments running throughout the cosmos, leaving huge spaces between them. These voids, comprising nearly 80% of the observable cosmos, vary in size from 30 to 300 million light-years across. Thus, the Boötes void gets the moniker of supervoid given its status as one of the largest voids in the universe. The occurrence of voids in the universe arises from the delicate dance of cosmic forces during its early stages. Initially, the universe was comparable to a dense, homogeneous soup of matter. However, random quantum fluctuations prompted minute differences in the distribution of matter. Some locations got denser due to these variations, boosting their gravitational attraction and sucking matter from less dense parts. This gravitational interplay resulted in denser regions and voids developing, a process sustained by the universe's expansion. As the cosmos expanded, quantum-level oscillations quickly stretched across huge distances, forcing smaller clumps of matter to cluster into galaxies while voids continued to develop. This dynamic interplay between gravitational attraction and cosmic expansion formed the cosmic landscape we view today, with galaxies gathering along filaments and enormous gaps occupying the intervals between. In recent years, astronomers at the University of Alabama in Huntsville, led by Chong Ji, discovered a stunning phenomenon. Utilizing upgraded telescopes, they found a massive cloud of hot, dimly lighting plasma in outer space, surpassing the size of the Milky Way galaxy. Surprisingly, this peculiar cosmic gas cloud has remained intact for hundreds of millions of years rather than dispersing into space. Analyzing X-ray emissions, the study team assessed the cloud's mass to be roughly 10 billion times that of the Sun. This revelation emphasizes the ongoing shocks awaiting scientists in their research of the cosmos. Dubbed the Orphan Cloud, its temperature range and location within the galaxy cluster of 1367, or Leo, indicated its origin from a galaxy within the cluster around 300 million light-years from Earth. The researchers believe that the cloud's cohesion over such enormous distances may be maintained by a magnetic field, preventing its disintegration despite leaving its home galaxy long ago. The vast magnitude of the cloud hints at the immensity of its parent galaxy. The discovery offers insights into galaxy evolution and may aid in pinpointing the cloud's parent galaxy, offering crucial data for future astronomical research. Observations of such clouds support the concept that the intercluster medium can strip galaxies of their gas, allowing views into the universe's early phases. Yet, each new finding underlines the grandeur of the unknown, stimulating reflection on our role in the cosmos and fueling the urge for more exploration.